Good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for the month of July. In this session today, we've got Tim Radney talking to us about the Azure SQL database for the production DBA. Now, before I hand over to Tim, just a couple of housekeeping that we'll go through. So I'd like to big call out to our sponsor, SQL Sentry. We've got here some parts from SQL Sentry that they provide for you, and easy access for you to get access to a lot of these articles, videos, training, etc. So feel free to visit SQL Sentry to get more of your SQL Server goodness. With that in mind, we've got the PAR Summit coming up in October of this year. Now we do have a discount code. If you use that, you get $150 off, and the rates are changing. So if you get in before the July 17, you'll save actually $400. So make sure that you sign up for that and come along. Also, if you do register and you use our passcode, you go in the draw for a chance to win a $500 Amazon gift card. So stay tuned for that if you do register for SQL Pass. Now these recordings are available after the session on the DBA Fundamentals website. As well with that, there'll be the slide deck available, and if there are any demonstrations, I'm sure that Tim will provide those as well. So with that, make sure that you stay involved. That you sign up for notifications of these sessions. They do run on a monthly basis, and make sure that you sign up for next month's session as well. So with that, I'll hand over to Tim, and we'll get the session rolling.
All right, can you confirm that you can see the slide deck?
Yes, your slide deck is up.
All right, fantastic. So as you've already been told and as you signed up for, this is Azure SQL Database for the production DBA. So thank you all for giving of your time and advancing your career by continuing your education. So without further ado, we'll go ahead and jump straight into the PowerPoint. So I am Tim Radney with SQL Skills. SQL Skills is a team of world-renowned SQL Server experts. You probably recognize some of these names, such as Paul Rendell, Kimberly Tripp, Glenn Berry, Aaron Stellato, and Jonathan Cahias. So I work with a stellar group of individuals. We do instructor-led training. We speak at Immersion Events, or our training events, or the SQL Immersion Events. We have several coming up in Bellevue and back in Chicago here in the US. We do online training with pluralsighto, health checks, anything from hardware performance upgrades, anything related to the core engine. We do remote DBA, system monitoring, troubleshooting, speak at conferences such as SQL Intersection and the PAS Summit, as well as user groups. The kind of takeaway here is if you're not a SQL Skills Insider, I encourage you to visit sqlskills.com/insider. Paul sends out a newsletter about twice a month. It's just chock full of kind of cool SQL Server tidbits. We usually include a SQL Skills Insider video with some cool thing that we've encountered or something that we've recently helped a client with, and it kind of needs more than just a blog post, so we record a short video, and so you get those links through the Insider newsletter. I mentioned our immersion events. We do everything from junior accidental DBA to 2 separate weeks for performance tuning. One of my favorite classes is the one on HA and DR. That kind of changed my career for me. We also have immersion events for business intelligence, SSIS, even machine learning with R. So I encourage you to take a look at those as well. And so who am I? I'm a consultant, trainer, speaker, author. Been with SQL Skills for about 1.5 years. You can check out my blogs at timradney.com or sqlskills.com/blogs/Tim. I am a data platform MVP, and some other stuff that kind of the takeaway from this one is the bottom line. I like playing with electronics. I've gotten into aquaponics, and I currently farm chickens, goats, cows, and tilapia. So I mentioned Pluralsight. This is kind of cool. If you're not currently a Pluralsight subscriber, I encourage you to become one. And what better way to start than to get a free month of all the SQL Skills content on Pluralsight. And you can do this by emailing paul@sqlskills.com with the subject line user group, Pluralsight code, and he'll send you a code good for 30 days of all of our content. There's no strings attached. You don't have to provide a credit card or anything like that. And we have over 144 hours of just SQL Skills content out there. So on to the actual session. What am I going to talk about? We're going to cover what Azure SQL Database is. I'm going to go over the features, some unsupported features. I'm going to do a few demos. One is creating an Azure SQL Database. I'll show you a couple of ways of doing that. And then we'll step through the DTU calculator, which will kind of be explained later in the session. And then we're going to talk about tuning differences. That's really what we're here for. As production DBAs with the on-premises or box version, as I call it, we know what to do. We know how to troubleshoot. We know how to tune. We know what we're looking for. But when this moves into the cloud, into Azure SQL Database, how is our job going to change? And so that's what I'm going to show you. So we'll talk about some tuning differences and various tuning options. And then I'll kind of demo some tuning options and show you it's really not all that difficult. So we'll get started with what is Azure SQL Database. So think about Azure SQL Database as a service. We hear this buzz as a service, platform as a service, infrastructure as a service. And so we've gotten familiar with those concepts. So this is database as a service. So the SQL engine is already there, and we just start putting data in it. So it's SQL Database is a cloud relational database service. It provides predictable performance and pricing. So what that means for us is it's consistent. If you run a particular query, it should perform the exact same way every single time. And as you need to scale, you can do so by increasing your performance tier. There's elastic database pool for unpredictable workloads. And I'll talk more about that later, but think about having just a large bucket of DTU or performance, and that's shared or can be shared and throttled amongst a whole lot of different databases. So you don't have to buy a whole lot of bandwidth for every single service. You just have a big pool. And like I said, we'll cover that more on a few slides. Currently, Azure SQL Database provides 99.99% availability, and that's built in. That's pretty good. 4 nines built into the product. That's like millions of dollars of infrastructure that you would have to have for your data center to provide that type of availability, and you get that just for using Azure SQL Database. Geo-replication and restore services for data protection. That's pretty cool, and we'll talk more about geo-replication throughout the talk. It supports existing SQL Server tools, the libraries and APIs. So SQL Server Management Studio that we're used to using connects into Azure SQL Database, as well as many other third-party tools. You just point to the Azure SQL Database and they continue to function. You have scalability with no downtime. That's impressive. So if you need to scale up, you literally flip a button or you click the tier that you want and you're migrated to that tier with no downtime. And then Azure, there's tons of security features and things built into the Azure product that we now see in SQL Server 2016. So secure and compliant for your sensitive data. So for me, being a production DBA, backups are kind of the most important thing to me. I need to be able to recover my client's data, and so I'm all about being able to restore the data in SLAs. So that's where I start with this. So backups. In this case, the backups are handled for you. They're handled in the background, and all we're responsible for is restoring the data. And you can do point-in-time restores. The retention is based on your tier, and we have 3 tiers. We have basic, standard, and premium. So your basic tier is 7 days worth of backups. Standard is 14, and premium is 35. And you can go back to any point in time within that retention period. So on a basic tier, which you can get for as little as $5 a month, you can go to any point in time within the past 7 days. And with that premium tier, any point in time within the past 35 days. Now there's a little caveat. It kind of threw me when I first started playing with Azure, and that's when you restore a database, it restores to a new database. So you can't restore and overwrite your existing. So what you can do is restore your backup. So restore your database, it gets a new name. Then you can swap them out. You can rename the old database to something old, and then rename the restored copy to the production name, and then reconnect your clients. So this works pretty well, being able to do that. And in many cases, you may just need to restore the database so you can get back some data and you can insert into or fix the production database without actually having to swap them out. But the thing you have to be aware of is with Azure SQL Database, you're paying per database. So when you restore a database, you're creating another billable moment. So if you don't need the restored copy, once you've restored it, you need to get rid of it fairly quickly because you are incurring expense. And all of these slides are going to include a URL to more information about this topic. And these slides will be made available so you can go and read the additional articles and figure out everything that you want. And if you have questions, my contact information was on a previous slide, so you can email me at tim@sqlskills.com. I'd be more than happy to help you with any other information related to Azure SQL Database that you may have. So next, dynamic data masking. This is a cool feature. It can limit access to sensitive data by controlling how the data appears. So hopefully you played with data masking before, and for the most part we either have to modify the way the data is stored in the database and have a lookup table to translate between the masked data and the unmasked, so the sensitive data is still there somewhere in the database, or it's being handled at the application layer. With this feature, it's literally you click a few buttons and you choose which columns that you want to mask and then what type of data that it is. So if it's an account number and you only want to display the last 4 digits or the first 3 digits or whatever you want, you choose that and then it's handled for you at the database level. There's no physical changes to the data being made. So you simply choose the columns and then how you want it to be displayed. And when the person accesses that data, either through a select statement or a SSRS report or however they're accessing the data, they only see the masked data. So that's pretty cool. Now, if they have the ability to write their own queries, there's ways that they can kind of circumvent the data masking. But if they're controlled through stored procedures, views, reports, through an application layer, it's really a slick product. You can prevent them seeing full account numbers or whatever data you're trying to protect. You also have row-level security. This can restrict row-level access based on the user's identity. So think about it this way. You have a table that has both employees and customer data. You only want low-level employees, maybe think of financial sector, tellers, CSRs, things like that. Those on the front line, taking money, making deposits. You don't want them to be able to look up employee accounts. You want a customer service manager, so only managers or above. People of a certain hierarchy can see employee data. So based upon their ID, their user identity, you can restrict that within this table, they cannot see anyone where employee status equals 1. They can only see employee status equals 0. So all that logic is located in the database tier, so that you're not having to build it into the application. So based upon their group or their role, you can prevent them from seeing certain data. So that's kind of a nice feature. And then we have always encrypted. This one kind of takes things to a new level. It allows clients to encrypt the sensitive data inside the client applications and not reveal the encryption keys to the database engine. So if you're familiar with TDE, where we're encrypting the database at rest, and that logic is built, stored within the database, and the DBA team still typically had access to the unencrypted data, this kind of takes that away from us. You can encrypt the data, and only those that have the access keys, which is the applications, servers, web servers, those tiers, can view the plain text data. So if we as the DBAs don't have that access key, we can't go and read the data within the database. So that's really cool, and you can store these encryption keys in the Azure Key Vault. So you have the mechanisms for the key management built into Azure as well. So I anticipate seeing this feature used pretty heavily. We still have transparent data encryption, just like with the box version. You get real-time encryption and decryption of the database, your backups, transaction log files, all that data at rest. It encrypts the storage of an entire database by using a symmetric key. So again, things that we've been used to for a few versions now. However, currently, Azure SQL Database does not support the Azure Key Vault integration with TDE. That's something that we may see in the future, and honestly, I haven't looked in the past month to see if that's been introduced. One of my favorite features is geo-replication. So this is available in your standard and premium tiers. So what this does is provides a replica database. So you have a secondary in a different region. Your estimated recovery time is less than 30 seconds with a recovery point objective less than 1 hour. With your premium tier, you get active geo-replication, which can provide you a readable secondary. This stuff is built in. So once you hit that standard tier, you have your data redundant, or if you enable it, redundant in another geographical region. If you're in that premium tier, you can set your geo-replica copy in another country, and it's readable. So if you have someone in another part of the country or part of the world that needs a read-only copy, then you can have that readable secondary there available for them. I mean, it's really slick, cool stuff. Things that we have to spend lots and lots of money to do with the box version, it's just built in. I mentioned earlier about the elastic database pools. I didn't want to give it all away, in the intro slide, but what this does is gives you a pool of resources. So I mentioned DTU, that's your database, I guess, I need to go and look and see if they finally settled. Is it database transaction unit or database throughput unit? I'm pretty sure we've landed on database transaction unit. So your elastic database transaction unit, so it's a pool of those that individual databases can auto-scale within a set of parameters. So think about if you had a software as a service application that you provide to your clients, and each client gets a new database, and you have 100 of these clients. Well, that's 100 Azure SQL databases. So what tier are you going to get? I mean, do they need 25 DTU? Do they need 100 DTU? Well, it could be one of those it depends kinds of moments. These clients are all over the world. Their workloads vary throughout the 24-hour cycles of a day. So maybe between the 100, on average, you're only using 25 per. So you only needed 2,500 DTU. But at any given point in time, one of them may scale up and need 500 DTU. With this, you can balance that load. An analogy I've given to others to try to help them understand is think about the whole thin provisioning concept of storage, where you have the big, huge SANs and your storage admin, you request 2 terabytes of data, and that's for 5 years anticipated growth. Well, when your database starts out, it may only be 500 gigabytes, but over time, you're going to grow to 2 terabytes. Well, your storage admin may not give you 2 terabytes of tier 1 fast storage that's $15,000 a terabyte. They may provision it, but on the back end, you're only using 50 gig, and you have this pool. So it's thin provisioned. Your system thinks it has all this room, but in reality, they're managing the storage on the back end. So as the storage need increases and their available amount of available disk decrease, they just add more storage. So it's kind of similar. Or your cable provider for your modem, your internet, says you have speeds up to so many gigabits or terabits. Well, you're on a shared resource. Everybody on your street that's connected to the same modem are going to pull some of that bandwidth from you. So in this case of elastic database pools, you purchase a large bucket of available bandwidth, and you can allocate that no one database can consume more than X. Maybe that's 500 DTU. But out of those, as they need up to 500, they can use it. And so you can monitor your DTU usage, and you see that it continually increases because you've grown from 100 databases to 120 databases or so forth. You can increase that bucket, but you're not having to spend 500 DTU per database. You're able to pool those resources. So under heavy load, this really helps you allow a particular database to consume more EDTUs to meet the demand without having to pay that price every day or every month. So provisioning resources for this entire pool really simplifies management rather than you having to be concerned about every single database. So this, I definitely see this feature becoming quite useful for those that are managing, say, 10 to 20 different Azure SQL databases for a single organization. Instead of allocating those dedicated resources per, you can just have that pool and then manage the pool. There's also in-memory support for the premium tier. I've seen this change a few times over the past, say, 12 months, where the in-memory support continues to increase. So as versions come out or the tiers continue to increase, we're seeing these amounts continue to increase. So this is available currently in the premium tier only. So some other cool features. Query Store. Hopefully we're all hearing about Query Store now that 2016 has released and includes Query Store support. So this provides you kind of the black box recorder. And my colleague Aaron Stellato has a Pluralsight course coming out on Query Store. Should be hitting the interwebs any day now. The course was wrapped up, should be through the production cycles and available. So keep a lookout for that. I know I am, because I really want to watch it and learn more about Query Store myself. But it is that black box recorder, so it provides you that detailed historical information about all the queries. So this enables us to quickly identify queries that are performing poorly. By this keeping history of each query, including its associated plans, the runtime statistics, information about resource consumption, we can see when queries are choosing different execution plans or when something was modified that caused them to turn sideways or to just become awful. So this can help you much more narrowly tune by being able to go back and see what the behavior was for those queries. Now there are certain things, the size that the Query Store takes up, some of these things are adjustable. And so that stuff I'm sure Erin is going to cover in her course, but you can read more about that at the URL. And this is database level features. So you don't have to turn it on for every database, and it is not on by default. So you have to go and enable that once you create your Azure SQL database. So to complement the Query Store, we also have the Index Advisor. So this provides index recommendations that have potential to improve current query performance. So I know we have the missing index DMV. We're all familiar with that. From what I've read about Index Advisor, and I definitely plan on digging much deeper into it, is using machine learning. So some of these algorithms that we're seeing, so it's applying some of those things. So it's not just a blindly index advisor or a missing index advisor kind of tool or DTA. This is truly supposed to be using some really cool logic and algorithms to help you realize where you have potential indexes that can aid in query performance. So I'm definitely looking forward to getting more clients using Azure SQL Database so I can see some real-world use cases for Index Advisor. Because there's only so much you can do with AdventureWorks. So I talked a lot about supported features, and we have some really, really cool stuff. But what are some of the things that we're used to as production DBAs that we're going to miss or that we can't do with Azure SQL Database? And then the biggest thing that kind of slapped me in the face was there's no SQL Server agent. So if I'm still responsible for certain things such as fragmentation and statistics updates and things like that, or even massaging data or lots of stuff, how do I run these things? If I don't have SQL Server agent to kick them off, what are my options? So one option is using an on-premises SQL Server agent. So something in my data center, I have a SQL Server and it's connected to my Azure SQL database, and I can kick off these jobs. Okay, that's cool. If I want something closer to my Azure SQL database, what I have heard most clients doing is just spinning up an Azure virtual machine running SQL Server. So they run a very lightweight, it doesn't have to be a beefy machine. You're just running SQL Server agent. So the lowest end virtual machine that you can get with SQL Server running, and then you run SQL Server agent there, and you can manage all of your SQL databases or all of your Azure SQL databases from that one virtual machine. So I like that approach. that can work very well. And I've seen some third-party products popping up to help with this particular problem as well. But it seems very simplistic to just have either SQL Server on a local on-premises connecting to your Azure SQL databases doing your maintenance, or just a virtual machine in the cloud. I like the approach of it being in the cloud, probably close to the same data center, so the things are there together. Also, there's no database mail. So that kind of hurt me a bit because I'm used to SQL agent alerts and things and getting email notifications when things aren't working well. You also can't use events notifications, and query notifications. So event notifications, that I use that a lot as well. SQL Server Trace and Profiler. Now we've known that's been deprecated since what, SQL Server 2014 or 2012. So the fact that it was not built into Azure SQL Database kind of makes sense. Trace flags. So 3226, 1118, 1117, these things that we're kind of used to when we build a SQL server, we can't enable. So that kind of makes sense. Most of these things, as we think about it, if Azure SQL Database, it's really just database containers. So Microsoft, in the Azure Data Center, is responsible for the SQL Server engine, and we're just getting databases, and we're really just contained databases within this ecosystem. We shouldn't be able to do anything at the instance level. We're just database as a service. So trace flags and trace profiler, those things kind of make sense that we can't do that. Agent would be for the instance as well. So as we kind of think through, it's like, all right, well, this stuff makes sense. But we also don't have SQL Server integration services. Log shipping, database mirroring, transactional replication, and the list goes on and on. Now, are any of these things showstoppers? Might be for you, might not. For most of my clients, none of this stuff in the unsupported features really matter. They use SQL Server as a data store. They're just pumping data in and retrieving data out. So the database mail agent, the workaround with the agent, not being able to set trace flags, all that stuff is moot for them. Now, other clients, I mean, it's definitely a showstopper, because they do transactional replication elsewhere, the high availability, but with geo-replication, you get some built-in HA, but you might not be able to meet the SLA of no more than 5 minutes data loss kind of thing. So you have to look at it from what it is, and for most small and mid-sized companies, this is a very, very viable data store, and it's cheap, which you'll see in the coming slides. So let's switch over and we'll take a look at a demo how to create an Azure SQL database. And I talked about DTUs, so the database transaction unit, and what that means, because one of the top questions I get when I start talking with an individual about Azure SQL database is, okay, well, what size Azure SQL database do I need? What pricing tier? How many DTU do I need? And with that, we're very fortunate that a very smart person was able to put together a DTU calculator. And I'm going to demo that. So we're going to first do creating an Azure SQL database, and then I'll immediately show you the DTU calculator, how to run the tool, and how to read the results. So 2 quick demos, and then we'll come back to the slides. Okay, so we're going to start with creating an Azure SQL database. So we'll start in the Azure portal. If you're not familiar with the Azure portal, this is my account. When I log in, you have your tiles on the home screen. I haven't really played with it a whole lot to go through and create custom tiles and so forth, but one of my favorite things is the service health. When you click on it, you see all of the Azure data centers in the green check mark. If any of them were having a problem, they would turn yellow or red. So we can see that all the data centers are healthy looking and looking well. So I'm going to click on SQL databases. But first I want to show you that if you're creating something new, you do have the new button at the top. But when you click new here, you get to choose from all of the Azure Marketplace items. So virtual machines, web, mobile, data storage, data analytics, I just want a Azure SQL database. So for me, it's much easier to just click on SQL databases, and you'll see that I have 3 already created. So I have an AdventureWorks, I have an AdventureWorks 2, and then my personal one, which is Speaking Events. And my pricing tiers, I have 2 running in the basic tier and 1 at standard S0. So if I wanted to create a new database, from here I can click Add. So I get to provide a database name, so we'll call this Down Under, and my Azure subscription account, or my MSDN account. So I have one for BizSpark, and then I also have a Visual Studio Enterprise. So if your organization has multiple MSDN accounts, or you're a consultant and you're working with different ones that you've set up, you can choose which subscription belongs to which database. So I'm going to stick with the BizSpark, and resource group I'm going to use existing, and I can choose between which region that I want to create this in. So we'll just stick with the South Central US. Select source, so I can either do a blank database. So if I choose blank database, I just get the container, and then I can run my script to create all the schemas that I want. I can also choose a sample, or I can choose to restore from a backup. And an Azure backup, not from on-premise. So we'll start with just a blank, and then I choose which server. I already have one created, but I can go through and create a new server to put this on, but I'm going to stick with the server that I already have. And then pricing tier. This is defaulting to an S2. You want to make sure if you're playing around with your Azure subscription that you change this, because an S2 can cost you some monies. And the pricing is currently loading, so we'll give it a few seconds for it to load. And all right, so it's here. So an S2, we'll start at the top. We see that a P4 is $1,860 for 500 DTU. The max that you're going to see is 1,750 DTUs for just over $7,000 a month. Now an S2 would cost me $75.02 per month. So if I let it default, it's going to take $75 from my account, or that's what it would be per month. So it's prorated. Now my Azure credits, I get 150 a month. So I could run 2 of these and then use my credits. So I like to stick with the basic, which is $4.99. So I'll choose the basic. Gotta hit select, and then I can choose my correlation. And my only option from here is create. So what are some of the things that you're used to being able to specify when you create a database on the box version of SQL Server? Number of data files, for one. Location of data files. The size of the data files. Auto growth. All those things, we don't have an option here. So I can click create, and it will go provision this this basic database. So I'll go ahead and $4.99, we'll let it create. Now from within SQL Server Management Studio, if I wanted to create a database, I could say new database, and then I specify a name. Pretty simple. And it will create, because I'm already on the existing server. I can't create a new server from here. I have to do that in the portal. So if you're kind of compartmentalizing, then it's best to do these things within the Azure portal. So switch back over to Azure portal. We'll try to refresh. And it's still provisioning my new database. So here we go. It is now created, and I can connect through Management Studio to this database. I could run and create whatever schemas I wanted and start ingesting data into it. So how do we know which DTUs that we need? We saw from the pricing tier, you can go up to 1,750 DTU. There are different features within each database tier, such as basic, I only have 7 days worth of backup history, no geo-replication. Standard gets me geo-replication and 14 days for backups. Premium was the active geo-replication, in-memory support, and then also a larger size. I can only go up to 2 gigabytes with basic, and up to, I'd have to look back at the chart, but I think it's 250 gig with standard. So let's take a look at this DTU calculator. So we do have the DTU calculator.azurewebsites.net, and it gives you the overview and tells you all about how it's collecting and what it's doing, and gives you the option of downloading. And then it also has the Elastic Databases option. We're going to look at the Azure SQL Database option, and the script is going to collect processor information, logical disk, as well as log bytes flush per second per the database that you specify. And then you can download the command line utility. Once you run the utility, you specify the number of cores for the instance that you ran it on, and you upload the file. So I've already run the files, but what I want to show you first is the actual script itself. So it's a PowerShell script. If we open with a Notepad, we can take a look, and it gives you some background information. It tells you that the counters are collected every second, and it defaults to 3,600 seconds. I've modified mine, so mine's going to run for 60 seconds, and you can specify the path. So mine's going to output to C Azure SQL perfmon log CSV, and then also it lists your the logical disk twice. So it's pulling reads and writes. So if you have your data file on one line and your log file on the other, you want to specify the respective disk. So this virtual machine, everything's on C. So I left it default to C. So we'll go ahead and close, and we'll run the PowerShell script. So I'll launch it by executing the SQL-perfmon.ps1, and it prompts me for which database I want to collect this information for. Since SQL Sentry is a sponsor, and this is my SQL Sentry virtual machine, I will let it run against the SQL Sentry database. So this will run for 60 seconds and create a file. Well, I've already got some files from various workloads, and so one came back as basic, premium, and standard. So I wanted to be able to show you all three. So we'll go ahead and upload those. So I'll choose the file, and my basic was running on a 2 vCPU, and this was run against actual production workloads, not just a mock-up virtual machine. So this came back and told me that 94.92% of my workload was in the basic tier. I can scroll down and look at the DTUs over time, and we'll see that we did have a spike up to 125 DTU at one point in time. But for the most part, this thing stayed under 5 DTU. So in this case, a good starting point for me would be a basic tier. You know, this could have been some ETL process or something that kicked off. Maybe it ran for 2 milliseconds, and on a basic tier it may run for 6 milliseconds. That's probably okay. So what if I had a higher workload? So let's take a look. We'll choose another file. This was on a 4 vCPU machine, and we'll calculate. So this one comes back and tells me that a standard S3 would be the good starting point, that 91.97% fell within the S3 or under, but there was 8% of the workload that falls into a higher service tier. So we'll take a look, and for the most part, 100 DTU, which is the S3, is sufficient. I do have some spikes up to a P2. So with this one, I could start with the standard, and if it's not performing adequately, then I can move on up to a higher tier. So I took one of the largest machines that I had, that I work on, and ran the DTU calculator there. This one came back and said 87% into a P4. 12.84% is higher than the P4. So this one spiked at a P6, which is 1,000 DTU. But we can see that was not all that long of a duration in that high of a tier. 500 in the P4 was pretty good, and we had dips down to an S3. So starting with a P4 would be a good starting point, but again, these are just a scientific guess. I mean, it's an algorithm, it's been vetted pretty well, but your mileage may vary. So this is a place to kind of start, and be prepared if you're having performance issues, you may need to move on up. The other thing is this defaults to run for 3,600 seconds, which is an hour. You need to run this at different points in time of the day under different workloads. You want to make sure that you're getting a really, really good sample of what your performance is like and what your workload is. So don't just run it for some random hour, a lull in your workload, and think that it came back instead of P4. It may be, a P7 is your starting point. So with that, very simple to run. A script, again, it's collecting that information every second. You upload and it gives you a good starting point. So we'll close out of here and we'll switch back over to our PowerPoint. So I showed how easy it is to kind of step through and some of the limitations with creating your Azure SQL database. Again, we don't specify location of the files, the number of files, all that's chosen for us. And then determining your DTU starting point. Like I just showed you, we have a good calculator that gives us that starting point. So with tuning differences, what are our options? What are some of the things that we can do? What are some of the things that we can't do? Now, me being an engine guy, a tuning guy, a lot of what I do for clients is fixing their installs. And with Azure SQL Database, there's none of that I can really do. I can't go and tune TempDB. I can't create multiple TempDB data files. I can't pre-size. I can't set trace flags on it. Can't do any of that stuff because that's instance level. Again, we're just playing in the database space. You can't modify cost threshold for parallelism. You can view it and it's still set to 5, but you can't change it. Max degree of parallelism, min and max server memory, optimized for ad hoc workloads. Anything requiring an SP configure or reconfigure is off limits. You just can't do it. Global temp tables are not supported. This one got me when I first started playing with Azure, and I was using some of Paul Randall's scripts, the wait stats and the wait stats over time and the file stats over time. And those scripts were using global temp tables. They're not supported. Also, the way that I go through and tune, I like to free the procedure cache and then kind of start from there. That way I can see what's happening right now, not things that have been kind of accumulated over time. And you can't run DBCC free proc cache in Azure SQL Database. So with that, what are our options? Now, if you've already tuned, your code is solid, you've got the proper indexes, no implicit conversions, all those things are done. You've tuned all the code. Well, you have to move to a higher tier. I mean, it's that simple. If you started off in a S1 with 20 DTU and your workload has increased, congratulations, your workload has increased, so should your cash flow positive. So you need to move to a tier that supports your new workload. So you would move from an S1 to an S2 or maybe an S3. So that's an option. Now, the difference here, in our current world with virtualization and physical hardware, most of us have gotten away from the physical dedicated servers and we're virtualized. And being able to ask for more memory, it's almost now a soft cost. It's built into the infrastructure with the availability. Usually it just takes a service request or an email, might not even require a purchase order within your organization. So asking for more resources for a faster performing virtual machine. Can I get some extra CPUs, some more memory, move to a faster disk, a faster host? Those things just happen under the covers. In this world, if you're paying for an S1 and you move to an S2, that's real dollars. So it kind of changes. So this can't be just your knee-jerk, hey, we're having performance issues, move to a higher pricing tier, because somebody's going to see that bill. So we've kind of gotten away from throw hardware at it to we now got to fix all this code that we've been able to ignore for years because we were on blazing fast disk and lots of RAM and all those things. So we're kind of back to fixing bad code. But again, if that stuff has been done, it's very simple to just move into that pricing tier. And this is a really good slide to look at because this is showing some of the differences between your basic, standard, and premium. So with the standard, up to 250 gig database. Your premium, 500 gig, up to 1 terabyte if you get into that P11. So in some cases, your tier may be warranted by the amount of DTU that you need, or the size of database that you need, or even some of the disaster recovery. So if I need active geo-replication that gives me 4 online readable secondary backups, then I might have to move to a P1 even though I may only need 20 DTU. Or if I need 35 days worth of backups, that's a minimum of a P1. If I need OLTP storage, again, that's premium, and the amount of OLTP storage is based upon your tier. So all those things, I mean, again, concurrent requests, logins, max sessions, some of those things, they increase with the tier of your server or your database. So things to consider. So when you start looking to move, you can validate that your backup supports Azure going through the Azure wizard, or and then if all that's good, then you're running the DTU calculator to figure out where you'll land in the basic, standard, or premium tiers, and just kind of walking through that process. So some other options. I mentioned Paul's script, so it's file statistics and file statistics over time. So when I started playing with the Azure SQL database, I went to my go-to script bucket. We all have those. So with that, with Paul's scripts, I just had to make a few changes. So the file statistics, sys master files does not exist. So I had to modify it to use sys databases. And then file statistics over time, again, same logic, sys master files did not exist, so I had to switch it over. I mentioned about the global temp tables not being supported, so I changed to local. And then the way that it was referencing from the global temp tables, I changed from to check using the object ID instead. So those things, very simple changes, didn't take much time, and then I can use that same script to be able to determine which of my databases are being or have the highest I/O latency. And then with the weight statistics, there's still things that we can be concerned with there, even though it's in the Azure SQL database. So with the weight statistics, the sysdm OS weight stats, that contains the weight statistics for the container, not just my particular database. So we have a new DMV with the Azure SQL database, which is sysdm DB weight stats. So that's database specific. So even though Paul's script included a whole lot of excludes for all the benign weights, those are still valid. So you just modify that one from sysdm OS weight stats to sysdm DB weight stats and run the same query. However, the weights over a period of time, I had the same issues with changing from OS to DB and the global temp tables. So all of that I documented in a SQL performance article entitled Getting Started Tuning Performance in Azure SQL Database. So that bit.ly link you can follow, and it steps through and includes some of the code snippets that I had to change. But you'll see me run some of those in a demo, which is now. So switch back over to the virtual machine, and this one's kind of fun. So we'll go ahead and pull up. This is Paul's standard script. I mean, verbatim copy paste from his blog post, and you'll see that it's referencing sysmaster files. So when I tried to run it, I got invalid object name sys.masterfiles. So once I changed that, then there were references to the master files table. I had to fix those things, and then I was able to run the query with no issue. So when I get started tuning, everybody, it's kind of a different art. I mean, some people, they start looking at different things, and one of the things I like to do is not just jump in the highest disk, I/O query or the highest CPU. One of the things I like to look at is which queries or execution plans are being reused the most, because it could be that I have one query that's taking 4 seconds to run, and it's being called 100,000 times a day, because it's some sprock that every button you click it references. So this thing, it's 4 seconds times 100,000 times. If I could tune that and get it down to sub-millisecond, I could make a drastic difference in this in the database performance. So when I do that, that's one of those situations where I typically like to free the procedure cache, especially to get to be able to get rid of the cache plans. Well, in this case, if I run one of the queries that I use, and I say that this particular query has been called 76 times and 10 times, and in the real world, this thing would have tens of thousands of records, and it would be almost impossible for me to determine in an active system, whether this particular query was updated, right? So if I try to run the free proc cache, I get user DBO does not have permissions to run dbcc free proc cache, because that would free the procedure cache for the entire instance. And I don't own the instance, I only own a database that's running in a container on the instance. Now, good news, with some of the documentation that's been coming out for 2016, we learned about alter database scoped configuration. And in digging through that, and with major assistance from Glenn Berry, who had discovered all this, he said, oh, why don't you just try to alter database scoped configuration, clear procedure cache. So we run that, command successful, we rerun the same script, and it freed the procedure cache. So we lost all that, the cache plans and all of that stuff. So it truly gave me the same benefit of free procedure cache. So cool. The I/O latencies, I mentioned that I had to make a few changes into that script, and then the waits over time, we changed to drop the table using object ID, and I changed the script to use DMDB wait stats. So each one of these I'm going to run for 1 minute, and then I'm going to run a few scripts to do some random searches and things, and then we'll go back and look and see, okay, do we have anything that we can tune? So we'll go ahead and kick off these two scripts. That one's not the overtime. Short period overtime, we'll execute, and then my demo. So I'm just going to run two scripts, repeat 25 times and 50 times. We'll let this run a few times, and then we'll come back and take a look and see if there's anything that we can tune. Now, while this is running, I wanted to show you if you have a local database. So we're going to go into my local instance called SQL Sentry, and I have a database called Speaking Events. If I right-click, I can go into Task, and then I want to export data tier application. So if I export data tier application, I'll click Next. Prompts me where I want, where do I want to save this backpack, and I can save directly to my Azure Blob storage, which I would recommend if this is a very large database. You can go ahead and create the file and get it into the blob storage, so when you do the import, it's much quicker. But for this case, we're just going to write something local, and we'll call it down under, and then we'll go Next, and then Finish. So it's going to take my Speaking Events database, and it's going to create a backpack of that database. And then from there, we can go to the Azure database server, or my container, and I should be able to import this particular database. So we'll come back here, and we'll say Import Data Tier Application. Next, and then I can browse out to it. And then Next. And then I can specify database name. I can choose the down under. It's going to try to use the standard S2 again. I don't want to use S2. I want to use the basic. And I can say Next. And then, oh, that's right. We already created a down under database, so we'll call it down under 2. Next. And then it should go and create that database, import the data tier application, and be good to go. So we'll leave that running in the background, and then we'll come back over these two queries completed. So we'll take a look at the I/O latencies over time, and we'll see that my AdventureWorks 2 data file, so this is file ID 1, which is the MDF and the LDF. So 103 reads, but we'll take a look at latency. I had a read latency of 566 with a write of 4. So that's some pretty bad latency. So with this data tier application, or this basic tier database, I have some serious read latency, but again, this is the lowest tier that I can possibly get. And then my waits over time, so SOS scheduler yield, it was my top wait, and then page latch. So we would, or page IO latch. So we would anticipate page IO latch since we're having such high latencies. Now if we look at the overall latency, so this is cumulative since the Azure or AdventureWorks 2 database. I don't know how long this goes back. That this database has been up for months. So average read latency of 172, write latency of 11. So if I just check right now, this is skewed data. So I would still want to see the I/O period over time, because this would still determine your read latency versus write latencies and what you can do. So from here, I would think, okay, read latency of 566, I probably have an index issue because I'm searching and searching and searching. So what we were doing is selecting from a particular table where a sales order ID equals a value. So if we take a look at the use counts, we see that this particular query executed 50 times in 1 minute and 25 times in a minute. So if I take a look at that particular query and I want to look at the actual execution plan, we see that we have a table scan. What do we do if we have a table scan? Well, we're scanning the entire table. This is a very big table. There's like 5 million records. We need an index. So if we create the non-clustered index for this query, it'll take it a minute. Look, our data tier import. So it checked everything. Now we're actually importing the database. Our index is still creating. Shouldn't take much longer. Let's refresh here and see if we see the first down under. All right, so our first down under showed up, and we have our down under 2 that's showing up now. So we now have our index. So if we go back and we run the query again, we take a look at our execution plan, we have an index seek. So our current subtree cost is now 0.005, whereas before I want to say it was 5 point something. So a big improvement for this particular query. So this is really no different than what we do with the box version of SQL Server. We tune, we look for high-cost queries. We try to fix those queries either by fixing the code itself, the stored procedure, or we have to index properly for those queries. None of that goes away with Azure SQL Database. If anything, it's more critical now that we tune code than before, because now we're paying for the performance tier rather than in the box version, we can just increase virtual CPU or memory or move to faster disk. It's an infrastructure problem, whereas here it puts it back on the DBA. So I foresee DBA skills with tuning really becoming a hot commodity within the Azure SQL database. So take a look back. This was successful, and we have our down under 2 database. We can expand tables. We see that we have my DBA events, and that was the speaking events table, and we have DBA events. So we just took a local on-premises database, exported the data tier application, and then turned around and imported it into Azure very, very simply. And we take a look at our SQL databases, and we see the 2 databases that we created. So really cool stuff. Back to the PowerPoint. So we talked about what is Azure SQL Database as the database as a service. I stepped through a multitude of features, and a lot of those features we now see with the SQL Server 2016 on-premise version. I talked about some of the unsupported features and how those can be some showstoppers depending on your organization and the needs, but also how there's workarounds to some of those limitations. I showed you how easy it is to create an Azure SQL database from just creating a blank database, creating a sample database, and even importing a production database live with you. I showed you the DTU calculator, which can give you a starting point of knowing where to or what size DTU or pricing tier that you may need. Then we talked about some tuning differences, how we really can't do anything from an instance perspective, but from code tuning and making things just go faster, we can. And then stepped through some of those tuning options and included several demos. So with that, I want to thank you all for attending, giving of your time to learning about Azure SQL Database, and I'll turn it back over to the organizer.
Thanks, Tim. Thanks, everybody, for coming along. So, Tim, to round out, we do have a couple of questions from some of the attendees. Now,
okay.
If we run through those, so one of those you kind of brushed on just now, but the role of a production DBA will decrease by moving to the databases to Azure. Is it a threat?
Absolutely not. I mean, as you saw, the only thing that is really goes away is the instance configuration items. But tuning and the organization and managing everything through the Azure portal, we're still responsible for index maintenance, statistics updates, all of those things are still on us. So I don't see that going away at all. If anything, it's making it easier for clients to spin up a production class, enterprise class, SQL database in the cloud and have features like geo-replication and built-in HADR to make it even more appealing rather than going with Postgres or MySQL or things. So I honestly see our role as a production DBA becoming more critical by tuning and making these things be able to run efficiently on less costly tiers of Azure database. Also getting more creative with Azure SQL database, we can't partition data. You can still split the stuff out and have smaller databases. So the multi-terabytes and things, I mean, no, I see our job as architecting data, the databases themselves, the tuning, being much more of a commodity and need than it is currently. I don't see much of anything other than installing SQL Server kind of fading out.
Okay. So with creating an Azure DB, what sort of approaches have I got to create it? Am I limited to only the portal? Can I use T-SQL? Can I use PowerShell? What have I got available to me?
So I know with T-SQL you can still create PowerShell. I want to say with the PowerShell you can get everything that you could do through the Azure portal. PowerShell is really an integral part of provisioning and administering Azure SQL database. I mean, you can do so much with it. I'm not a big PowerShell person myself, but I'm having to learn more of it in order to do some things within Azure. And doing stuff through PowerShell allows you to automate and script and have canned things where it's repetitive and the same standards. Through T-SQL, I think there's still more limitations than through the portal and PowerShell.
Okay. And our last question for the day, one of the options which isn't supported with Azure SQL Database is SSIS. Now, what have we got available to us? Traditionally, we could use SSIS to extract data, move that data from a database to somewhere else, do some data manipulation. What have we got access to be able to do a similar sort of thing against an Azure SQL database?
SSIS on a Azure virtual machine. So there's no add-in like within Azure SQL database currently where you can choose SSIS to build things, but in full-blown SQL Server on an Azure virtual machine running integration services can connect to an Azure SQL database. SSIS is one of the top methods for migrating on-premises data to Azure. So you can connect to it all day long. It's just there's not an option within the Azure portal to say SSIS to have it running as a software as a service. So just like you would for SQL Server Agent, you run integration services on a dedicated VM and let it do all your ETL.
All right, so it just sees that the Azure SQL database is a data source, just like anything else.
Correct. Yep, just like you can also do with reporting services and other things. It's just a data source.
There we go, everybody. Once again, thank you, Tim, for coming along and presenting here for DBA Fundamentals Down Under. My name's Warwick Rudd. I'm your host, and I hope to see everybody back same time next month. Thank you.